Hello friends, I'm Nihar and you are on Easy to Learn channel on YouTube. Okay, now I'm writing a program to check whether a number is an Armstrong number or not. To REM statement. Now what is an Armstrong number? I told you in my earlier videos concept of Armstrong number. Suppose 153 is a number. The sum of the cubes of its digits should be equal to the number itself. Suppose 1 cube plus 5 cube plus 3 cube, that is the sum of the cubes of its separate digits should be equal to 153. The sum should be 153. 1 plus 1 cube is 1, 5 cube is 125, 3 cube is 27, and this total sum up to 153. So this number is an Armstrong number. So we have to check this concept. Now our the main problem area is how to separate out the digits. Everyone know how to find out the cube, everyone know how to find out the sum, but the problem is how to separate out the digits. For this I have already discussed in my earlier videos, but I will again discuss it here. Write a program to check numbers with Armstrong or not. I have written the REM statement. This is for my reference. I have already told you many times, REM statement is for the programmer. When he comes back to this program and he checks the first line, he understands what the program is all about. For 20, the next statement, I will be taking an input because I have to check for a number. So the user will enter a number. Input, enter a number. Suppose I have taken a number n. Now let us take another variable k, which will store the value of n. And now we will keep on reducing this number n, or maybe k. You can take any variable. We'll chop out the digits. Either we can take n, which stores 153, or we can take k, which stores the same value as n. Now I am taking k because I have used this variable, so I'll be taking k variable. K is equal to n means the value of n is now stored in k. The statement means this. That is, now k also stores the same value, whatever is stored in n, whatever user has entered in n variable. Okay. So I am using a while loop. While loop will continue until the value of k is more than 0. After reducing the value of k until the value becomes 0, we'll keep on reducing until it becomes 0. The loop will be repeated. Now why I am doing this, I'll tell you in the dry run. First of all, the statement is I am using a modulus operator, which will find out the remainder after dividing the value of k by 10. Another for reducing the number, we will be reducing it by dividing it by 10, and now changing the value of k. These are the three main steps that we have to do. Next is the processing. I'll have to find out the digit is chopped out in a. Then I have to find out the cube. For this I am taking a variable c, where I will be calculating the cube. Another variable which I have taken in 35 as s is equal to 0, the initial value, so that it does not contain any garbage value. S is equal to s plus c, that is storing the cube. The sum of cubes, I am finding out the sum of the cubes. 100 is wend or end of while, and 110 is the checking part. Now if the sum of the cubes is equal to the value n, then print Armstrong number, else print not Armstrong. Now this is what we have what was to be checked in this program and end. Now what we are doing is we are taking the input. There are three parts in this program. The input, the process is long enough this time, and the output. Output is a conditional output because the output required is conditional output, whether the number is Armstrong or not. So if the number is Armstrong, it will print Armstrong, else it will print not Armstrong. So what are we doing in this program? See, I am storing the value n in variable k because we will keep on reducing the number. How we will check that the original number entered is equal to the sum of cubes or not. Okay, and then I am taking a variable s which will store the sum. Initially I am taking 0 because I will be keep on adding the values. So initially it should be taken as 0, otherwise it will take a garbage value. The result will not be as desired. Then the loop will continue in the 40 statement. The loop will continue while k is greater than 0. Until and unless the value of k remains more than 0, the loop will continue. Okay, now how it will work, I am doing the dry run. Just see, for dry run I am taking the variables k, n, a, b, c, s. Okay, suppose I have taken a number n as 153 after the input. So the k will also be stored in n. K will have also the same value as n, that is 153. S will have an initial value 0 while k is greater than 0. Yes, it is true. The loop will continue. A will have k mod 10. Now what is k mod 10? 153 mod 10. After dividing 153 by 10, what is the remainder? If you don't know, you have not seen my previous videos, I am doing it rough work for you. 153 mod 10 means dividing 153 by 10. That is, the divisor is 10 and the number is 153. 10 ones are 10, 5 remaining, 3 will be copied, 10 5s are 50, 3 is remaining. This is the remainder. Okay, remainder is not 0, that is not fully divisible. Remainder, there is something remains, that is a remainder, and that is 3. And then 153 mod 10 will be equal to 3 as calculated here. See, okay, b is k divided by 10. After dividing, this result is 15 divided by 10, 15.3. We will take the integer part 15 because these are, I am supposing they are the integer variables. Now k will store the value b, and that is k is changed. Now k is reduced, number we are reducing, then only we will get the other numbers. Then c will contain the cube of a, that is 7. A is 3, cube of 3 is 27. And S will contain the sum 0 plus 27, that is 27. Now when it will again go back to the condition and it will check k is greater than 0, true, the loop will continue, a will have k mod 10, now 15 mod 10 will be 5. We are not touching the value of n, that will remain 153. Why? How it is done? See. 15 mod 10. 10 after dividing 15 divided by 10. 10 ones are 10. Remainder is 5. It is not divisible. This is the remainder. This is how we get 5. 15 mod 10. Now B is 15 divided by 10. That is 1 because 1.5 is 1. Now see, k will be changed. Now k is 1, again reduced. C is cube of a is 5, cube of a is 125. Sum is s plus c. Now s was 27 and now 125. What is the result? 152. Again it will go back and check k is greater than 0. Yes, k is 1. 1 is greater than 0. True. It will again come back in the loop. A is 1 mod 10. Now if the thing in maths also and in this modulus operator, if the value of k is less than this divisor, remainder is k itself. Okay. 1 cannot be divided by 10, so the remainder will be 1. So a will be 1. This is how I'm still showing it to you how it works. 1 mod 10. We cannot divide 1 by 10, so this is the remainder. Okay, clear now? B 1 divided by 10, it is 0. K is equal to B. K is now again reduced to 0. C is a cube. A is 1. 1 cube is 1. S is equal to s plus c. 152 plus 1 is 153. Again when we will go back, it will check 0 is greater than 0, false. This loop will end and we will come to 110. 110 checks if the sum is equal to n. S is this sum and number is this one. Because they are same, print Armstrong number. Armstrong number will be printed and else will be left unexecuted because this condition is true. This is the program for Armstrong number. Thank you so much. All the best.